In this session, we will discuss the questions related to motion, graph, and force. In question 1, which of the following statement describe the gravitational field strength acting on a body at a point? So we have the formula, the gravitational field strength, weight is equals to mass into gravity, or weight divided by mass is equals to gravity. So the gravitational force or the weight per unit mass, that is the gravitational field strength, or G. So in that case, B will be the right answer. In question 2, a ball of mass m is projected vertically upward and air resistance act on the ball at all the time. Which of the following would apply as a ball is traveling upward? So when it is traveling upward, the weight is acting downward, and because the direction of the motion and the direction of air resistances are always opposite, so if it is moving up, the air resistance will act down as well. So, and according to Newton's second law, that whenever there is a resultant force, the object will have acceleration which is equals to m. The formula which relates force, mass, and acceleration, that resultant force is equals to ma. So what is the resultant force on this object? Because the two forces are acting in the same direction, so it will be W plus F is equals to ma. That's why D will be the right answer. In question 3, two objects P and Q are at same position. The graph shows how the velocity vary. What is the significance of positive and negative velocity? If positive velocity, because if the direction changes, if one of the velocity we consider as positive, the other one will be negative. And so what happened for object P? First it moved towards one direction and then it returned back in opposite direction. So an area under the graph for moving towards right or left is same. So it means the overall displacement of this object will be 0. But what happened for object Q? As the slope is decreasing, so its acceleration is decreasing. So which of the following statement describe the position of P and Q at 4 seconds? Both are at their initial position. That's wrong. P will be at initial position, but Q will be away from the initial position. P and Q are in the same direction from initial position. For P, the initial, it is actually at the initial position, but for Q, it is towards one side of initial position. P is further from initial position. That's wrong because P returned back, and Q is further from initial position. That's true. So that's why D is the right answer. Is it clear, this question? In question 4, a ball is traveling horizontally at a speed of 7 meter per second. It hits the vertical wall and it rebounds. So initially the ball is traveling at a speed of 7 meter per second. It hits the vertical wall and bounce back. with a speed of 5 meter per second, and the ball has an acceleration of 300 meter per second square. So acceleration is given. Which of the following expression would give us the time interval? So because velocity is a vector quantity, so one direction you consider as positive, the other will be negative. And acceleration is 300 meter per second square. So we have the formula. Acceleration is change in velocity divided by time. So time is equals to final velocity minus initial velocity divided by acceleration. The final velocity is minus 5. The initial velocity is minus 7. Initial velocity is plus 7, but this negative is for the formula, and divided by time divided by acceleration, which is 300. And because, as you can see, the value, it was plus 5, sorry, plus 7, then it changes to 5, so the value decreases. So here it will be negative, or it will be deceleration, that's why it will be minus 300. So which option it matches with? It matches with option A. Is it clear? Because the value of the speed was decreasing, so it is deceleration, and deceleration is represented by a negative value. A popcorn kernel contained water. When heated, the water turn into steam and the kernel pops and move upward. So this is the initial position of the popcorn kernel, as shown here, and once it pops, that is the new final position. In the question, the photograph above shown a popcorn just before popping at a maximum height after popping. The time between the two photographs is 83 milliseconds. Determine the maximum height. So they provide you the scale. So we have the time, because this will have acceleration due to gravity. So we can use the formula S is equals to ut plus half et square, in which the initial velocity is 0. So S is equals to 1 by 2 gt square. So gravity is 9.8 and we have the time 83 millisecond. We can find the vertical height. There's also another way. If you see, they provide you the scale. So what you will do, you will place your ruler next to this to find out the relation between the 1 centimeter of the figure with the scale value. Like example, from this, for the scale value, it matches with 5 centimeter. So it means the figure size and actual size, what is the relation in figure? If it is 1 centimeter, actually it is 5 centimeters. So then you will measure this vertical height, and that is the figure size. So example, if that is coming out as 0.7, so figure size is 0.7, so this will be x. So you cross multiply. So it will be 7 multiplied by 0.7. Sorry, 5 multiplied by 0.7, which is equals to 3.5. So this is one way of getting the answer. You can use this figure, or you can use equation of the motion, in which you have S is equals to gt square, initial velocity 0, gravity 9.8, then half, and then t is 83 milliseconds. So 83 into 10 to the power minus 3 square, you will get the answer. Is it clear, part A1? Then calculate the initial speed. How we can work out initial speed of this? So we can use the formula for potential energy, the conservation of energy. The potential energy changes into kinetic energy. Potential energy is mgh. Kinetic energy is half mv square. M will cancel with m, so gh is equals to half v square, where g is a gravity, which is 9.8, h is a height, which we worked out in the previous part, half, and v square 2 is divided, other side multiply 9.8 into 3.5 into 2, and then take a square root. You'll get its speed, which will come out as 0.82 meter per second. Then the average water content in a popcorn kernel is 14% of the total mass. A kernel is heated until it pops. Steam is ejected downward and the popcorn kernel move upward with the initial speed of 1.5. Calculate the speed at which the steam is ejected. The total mass of the popcorn kernel is 0.11 grams. So basically what happened here, you will use a conservation of the momentum, that the total momentum before collision is equals to total momentum after collision. So initially, when the popcorn kernel does not pop, initial momentum is 0. So when it pops, the final momentum should be 0 as well. So if the kernel, the part is moving upward, the water content will move downward. And they should have the same value of the momentum, but in opposite direction, so the final momentum will be 0. And they mention that 14% of the total mass is there for water. So we will find 14% of this total mass to get the mass of water. So mass of water, or H2O, will be 14% of 0.11. So it will be 0.11 grams multiplied by 14 divided by 100, which is equals to 0.0154. That's a mass of water. And momentum before collision is equals to momentum after. So the total, that's a conservation of momentum. So total momentum before is equals to the total momentum after. So total momentum before is 0, total momentum after should be 0. So mass of the pop kernel, what will the mass of the pop kernel? Because if 14% is a mass of water, then remaining 86% will be there of 0.11 is a mass of the kernel. So mass of the kernel will be 0.0946 and the mass of the water is 0.0154. So 0.0946, and it move with a speed of 1.5 plus the mass of the water 0.0154 multiplied by speed at which the water is moving, that's v. And we solve this equation to get the value for v. So it will be 0.0946 multiplied by 1.5, and that is divided by 0.0154 equal to 9.21 meter per second. Is it clear, this part, at how we work out the speed? So this is actually related to topic momentum. Any doubt in this part? Then a box was placed at the top of a ramp and released. So this box was placed at the top of the ramp and it is released. The free body force diagram for the box as it moved down at the ramp with a constant speed is given. Which two forces acting on the box have, according to Newton's third law, corresponding force acting on the ramp? So how we can work out, like this object is there, which is on the inclined surface. So weight is acting downward, normal contact force is acting upward. And it is actually in this manner that object is placed on the ramp. So weight of the object is acting downward, normal contact force is there, friction try to resist, and there is also air resistance. And this is a drag or air resistance. So in the question they're asking which two forces acting on the box. So two forces which are acting on the box according to Newton's third law, corresponding forces acting on the ramp. So first thing, because the weight as it is acting downward, it will have two components. The friction is denoted by capital F in this example. So as the weight which is acting downward, making certain angle, so the component of a weight which is with an angle, that's W cos theta. So if W cos theta is acting on the ramp, the normal contact force R is there, which is acting on the box. And same thing, W sine theta is trying to cause or trying to make it slide down, W sine theta. But what happened? The friction tried to resist. So W sine theta is trying to move it down, but the friction force is there between the ramp and the box, or friction force is acting on the box to reduce or to does not slide down. That's why B is the right answer. Is it clear? The corresponding forces according to Newton's third law, that because the components of the weight are acting, one of the component of the weight is perpendicular to surface, that corresponding force will be R, and another component which is parallel to the surface, that corresponding force is F. In question 7, a car moving towards a stop sign at a speed of 25 meter per second. So that's the initial speed. The driver applies the brake 20 meter before, so that's a distance. and decelerate uniformly and come to rest, so the final speed is 0. Which of the following is magnitude of deceleration? So we have the formula 2as is equals to v square minus u square. Why we are using this formula? Because the time is not given. If we use a is equals to v minus u over t, but we don't have the time, that's why we cannot use this formula. So to deceleration, we are finding the distance is 20, the final speed is 0, and the initial speed is 25. So 2 multiplied by 20, that's 40, and that will be divided. So it will be 0 square minus 25. It will be minus 25 square divided by 40. And they are only asking for magnitude. They did not ask for sign. So it is minus 25 square divided by 40, but they are only asking for magnitude. So the magnitude will be equal to C. Is it clear, this question? This is a structure question. Transmission of electricity over a long distance required a conducting cable that is suitable to hang from a support towers called pylons. The vertical distance from the line of a support to a lowest point on a wire is called a sag. Due to the high voltage involved, the cable must minimum maintain a minimum distance from the ground, because electric field produce a magnetic field as well, the electricity. So to for the safety, it must have a minimum distance. Then they mention the temperature and the tension of the cable can affect the sag, because if temperature increase, it will increase the expansion will occur, so the sag will increase. Suggest one other factor that may increases the sag of the cable. So what could be the other factor which could affect the sag of this cable? The mass of the wires can affect, and the distance between the pylons. If the pylons are closer to each other, then the sag will increase for the same length. So if pylons are closer, the sag will increase. So the distance between the pylons or the weight of this wire, we just have to mention any one of them. So we can mention that the distance between the pylons. Then a cable of mass m at an angle theta to horizontal. Explain why the tension in the cable decreases as the sag increases. So this is the tension in the cable. So the component of the tension which is with an angle, that is T cos theta, and the component which is against the angle, that is T sine theta. And always remember, the value of the theta and sine theta are directly proportional. Like if you increase the angle, the value of sine theta increase, and value of theta and cosine theta are inverse. If you increase the angle, the value of the cosine theta or cos theta will decrease. So when we work out as the weight of this mass is there, so weight will act downward, and it is making the same angle theta here. So this will be T. The component of the tension which is with an angle will be T cos theta, and the component which is against the angle, that is T sine theta. So basically between the two pylons, the weight is balanced by T. t sine theta from each pylon. So the total, because it is at rest, so there is no resultant force. So we can say W minus 2t sine theta. Why I am writing 2 sine theta? Because t sine theta from one pylon acting upward and t sine theta from other pylon. So W minus 2t sine theta is equals to 0, or we can say W is equals to 2t sine theta. So weight is constant. They are saying as the angle increases, because the weight must balance with 2t sine theta. So 2 is constant. Only the thing which can change is sine theta or t. So we want the result to be constant. We want the result to be balanced with the weight. So if the value of the angle increase, if the value of the theta increase, the value of sine theta will increase as well. So if the value of the sine theta is increasing, the value of t should decrease, because we want the result of the product equal to the weight. So in answer you will mention that W is equals to 2t sine theta. If the value of theta increase, the value of the sine theta increase, so the t must decrease to balance with the weight, because the weight is not changing or weight is kept constant. Is it clear? This example. Then the next part, the graph shows how the acceleration of an object vary with time. Which of the following graph shows how the velocity, so basically what is happening, acceleration is increasing. So we know velocity time graph, the slope represents acceleration. So as you can see, the value on the y-axis, acceleration value is increasing, so it means the slope should increase. So which graph? In this graph the slope is decreasing, this one slope is decreasing, here slope is constant, and for D slope is increasing. That's why the acceleration is increasing. So D will be the right answer for this. Then which of the following statement is not correct for the Newton third pair forces? So when you have Newton pair forces, they should have equal magnitude, they should be in opposite direction, acting on two different objects, acting at the same time, acting on uh, same line, acting on two different objects, same type of forces should be there. The forces act in opposite direction, that's true. The force act on same body, that's wrong, because force act on different bodies. Force at same time, that's true. They should have the same magnitude, that's also true. So statement B is not the right statement. In this question, a ball is dropped and reach a ground in 0.42 seconds. The ball bounced and caught at the same height. Draw on a graph. Velocity time. Assume that the time of a collision with the ground uh, and all the friction forces are negligible. Show you're working in a space below. So ball is dropped and it reaches the ground. The ball bounces and it is caught at the same height. And it's a 5 marks. So first thing, when object is dropped from certain height, its initial velocity should be 0. And it should have a constant acceleration. So we will first find its velocity at which it hits the ground. So v is equals to u plus at. The initial velocity is 0, so acceleration due to gravity multiplied by time. So that is 9.81 multiplied by time interval, which is given in the question. That was 0.42. So this will be multiplied by 0.42. We'll get its final speed at which it hits the ground, which is 4.12 meter per second. So as this ball is being dropped, it will hit the ground with a speed of 4.12 meter per second, and it bounces back with the same, because it rises to a same height, so it does not lose any energy, and it rises to a same height, so it will bounce back with the same speed. So when we sketch a graph for a falling object, because initial speed is 0, so we'll label the axis. That's why it's having 5 marks. We have to label the time axis. So 0 0.1, 2, 3, 4, 5, 6, 7, 8, or I can increase this 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, 0 0.6, 0 0.7, 0 0.8. So 0.4, this is 0.4. So, and the speed value, because the value of the speed which we calculated was 4.12. So if I did, this is 1, 2, 3, and 4, and then -1, -2, -3, and -4, and so on. So it is 4 point, when 0.42 is there, that it reaches a height. So this will be, and it will have a constant acceleration. When it bounces back, with the same velocity, so 4.12, 4.12. So here it will be 4.12 as well. And then it will be 0, and we neglect this time interval when it rebound. So when we neglect, so at the same time, when at 0.42 seconds, it will have the same velocity of 4.12 positive and 4.12 negative. Is it clear? This graph for a falling object which rebound with the same speed. So in question 12, a skydiver jumped down on a plane and fell 50 seconds before he opened his parachute. The graph shows how the skydiver velocity varies over a time, over a 50-second. Explain the shape of the graph. So first, he's moving with a constant acceleration because it's a straight line, and we can say his acceleration is due to gravity. Then air resistance start to act. So as air resistance start to act, air resistance will oppose its motion. So resultant force is decreasing. That's why its acceleration is decreasing. Once the air resistance matches with the weight, so there is no resultant force, so there is no acceleration. So when you explain the shape of this graph, you have to use the concept of air resistance. So initially the acceleration is due to gravity. As the speed increases, the air resistance increases, so the resultant force decreases, which decreases the acceleration. And once air resistance matches with the weight, it will move with a constant speed or zero acceleration. The second part, sketch on a graph the motion of after he opens the parachute. So when he opens the parachute, his air resistance increase, so the force which is opposing the motion increase, so he will decelerate. then speed is decreasing, so his deceleration decrease again, and he will reach a constant velocity again, or a terminal velocity which will be lower than the first value. Explain the effect of mass on the terminal velocity, the constant velocity. If he's having more mass, he will have greater weight, and greater weight means he need greater terminal, he need a greater air resistance, and if he want to increase the greater air resistance, so he should have greater speed as well. How skydiver could decrease its terminal velocity as he fell. So if he want to decrease his terminal velocity, he should increase the surface area. So he should increase the surface area, or he should increase the drag force. So we can mention increase the surface area, which increases the drag force or air resistance, reduces the terminal velocity. And then skydiver jump was being filmed by another skydiver. Both divers jump out of the plane at the same time. During a period of filming, only the skydiver who was being recorded opened his parachute. When viewing the recording after it appeared that the skydiver being filmed above move upward as he opens his parachute. Explain this apparent movement. Like two skydiver jump at the same time, but the one who's recording, he opens the parachute first. So when he checking the recording, he observed that it appeared that he is moving upward in the recording. So why it appeared like this? Because the other skydiver is falling with greater acceleration, but the skydiver who's filming or recording, he's having zero acceleration. So or he first, when he opened the parachute, he slowed down. So as he slows down, so the skydiver who opened the parachute, he slowed down. That is why it appeared. And diver that is filming remained at a constant terminal speed. That's why it appeared that he moved upward. Is it clear? Is it clear, this part? So this was exercise related to topic motion, graphs and force. In the next session, we'll do more questions from this exercise.